So let's look at part B here, right? Determine the coefficient of dynamic friction between the stone and the ice during the last 14 seconds of the stone's motion. Okay. Well, during the last 14 seconds, the only force acting on this thing, horizontally anyway, right, is that force of friction, right? So the force of friction, right, is equal to ma, where I'm making the deceleration positive, okay? So ultimately, the mass cancels out, and that of course might throw you, right? It seems like, gee, seems like we need the mass of this thing, but we actually don't. Okay, so this is going to be sort of our strategy. This is, of course, 9.81. This is our acceleration, right? Okay, so the question is, what is the deceleration of the stone? Well, you know the initial velocity. The initial velocity is whatever you calculated for this, the answer to A, right? Okay, that's your initial velocity. You know the final velocity is it stops, right? And then you know that it takes 14 seconds, right? So you know those three things. You ought to be able to figure out the acceleration. You can plug the acceleration into this. You can plug 9.81 into that, and then you ought to be able to get the coefficient of friction. All right? Yeah. Happy hunting.